Hello there, kitties. I'm Carrie, the vacuum tube witch. Not in my lab. I'm in the local hackerspace and I'll be doing some destructive tests of electronic components with the test chamber that I showed you. And what is it all about? Basically, the test chamber has a power cable going in through the NC4 connector. Right now, two wires are used. There is the switch of death, and two alligator clips in here that you can connect with the device on the test. Right now we're having the 47 microfarad 16 volts connected, and the power supply here has 30 volts with a 2.5 amp current limit. Turning on the power supply, turning on the fume extractor, and wait for the sign to flip the switch of death. 3, 2, 1. Let's see what's happening here. The current is rising. 6 milliamperes, 8, 10. Yeah, it's rising more and more rapidly. This is the sign that the device under test is getting heated up. And right now, the current limit probably kicked in, and we've got the magic smoke! And of course the traditional bad capacitor stench. That's why I used the fume extractor here. The test is now concluded. Let's vent the test chamber and see the remains of the capacitor, or shall I say capacitor, because this was the leftover from the DJ mixer's recapitulation, and if you take a closer look here, it got completely ripped and torn. So let's look for a different part that I would like to test. Let's try 10 microfarad 16 volts from Elva, the old Polish manufacturer of electrolytic caps. First, let's connect it with the correct polarity. Wait for the sign to flip the switch of death. And it is 30 volts, but the current doesn't rise. Either it is damaged or it can hold out much higher voltages than it says. Aborting the test and inverting the polarity of the capacitor here. Now the polarity will be reversed. The positive electrode will go to the negative power supply end. So wait for the sign to flip the switch of death. 3, 2, 1. And yeah, we've got a lot of current flowing through it. And it has blown! An explosive and destructive test indeed. Very nice. That's why we use the fume extractors, and if you see the remains of the capacitor here, it's completely destroyed. There are a lot of remains inside the test chamber. It is now ventilated and pretty safe. To show you how it looks like, and I think I will have to wash the chamber because there is leftover all over the place, and the aluminum case of the capacitor got damaged as well. It just got crushed, so the mechanical energy of an exploding cap was quite large. Okay, so now let's move on to testing some resistors. Just wait for a moment. Co tutaj małego wziąć? 53 stronów, nie, sędzi są małe. 648. 68, 680, 802. 339 ohmów. So, back at the bench, we've got two resistors that I'd like to test. One of them is 10 ohms, half a watt MLT metal film resistor, and the other one is probably a carbon composition. It's 39 ohms, probably 0.25, probably a quarter of a watt or 1/8 of a watt, and let's put them to the test. The resistor is in place. Set the voltage. Two 25 by 40. Yes, this. Let's set it to 10 volts. It should dissipate a few watts. And wait for the sign to flip the switch of death. And it's got some magic smoke. Pretty nice magic smoke. It's getting darker and darker, and see if you see, it's getting hot. It's getting red hot, and it's burning. And now the current stopped. So the resistor is destroyed. Probably it's very hot now. The typical smell of a burnt resistor. So, it is considered officially dead now. Yeah, pretty warm. And let's move on to the MRT metal film resistor. And let's put it to 5 volts. Or maybe not. I think I should. Let's put it to 5 volts. That would give like 2.5 watts on a resistor rated for half a watt. And let's see what happens. Wait for the sign to flip the switch of death. And let's see what's going on. It is indeed half an ampere at 5 volts. That would be 2.5 watts. And the resistor is getting hot, it's getting burned. It's darker and darker. No magic smoke as of now. I think I'm seeing a little bit of magic smoke here. Let's raise the voltage just a little bit to 7 volts. See what happens. And the magic smoke is clearly visible. The current is 0.676 ampere and it is stable now. The resistor is almost black. But it is not failing yet, so it would be something like 4.5 watts being dissipated on the resistor, and being that it has half a watt rating, it would be almost tenfold of the normal value, and it's still going. The true gniocja nie łamiocja. Those Russians could make good electronic parts. Let's put it to something like 6 watts. And now we can clearly see that the varnish is completely burned, but the resistor itself is still going. It's not completely dead yet. Raise the voltage just a little bit more to 9 volts. Almost 8 watts dissipated on the resistor, and it's still going. Oh, come on! Just die already! 10 volts. And 10 volts on 10 ohms would be 10 watts of power being dissipated, and the resistor is glowing. It's red. It's burning pretty nicely, but still going. And it looks like the resistance has risen a little bit, because I would expect 1 ampere going through it, and I'm getting like 0.8 amperes, but still. Okay, let's do something to make it completely fail. Get it to 16 watts and see it glow! Burn, baby, burn! The current has fallen. It's 60 milliamps and it looks like the resistance has risen dramatically. Let's get it to the full, and it's still 0.2 amperes. Still some glow here. And it still conducts. So that would be it. Pretty much we were torturing and killing this little resistor, this little Russian Soviet resistor. I don't know what political impact it's gonna have in the current times. And yeah, that was the little experiment with killing the innocent electronic parts for the fucking fun of it. Okay, let's turn it off. And this is how a dead MLT carbon comp resistor looks like. And it is possible that I'm seeing the remainings of markings on it, but I'm not sure if that's really the case. Still, yes, I'm seeing things. The markings are still pretty much visible. Not so clear, but I can see MLT. So that would be it, I think. This little resistor has taken a lot of walloping. Normally it would just burn down, but those things don't fail that quickly. They are really die-hard parts, and I use these resistors because they are pretty common in Poland, and I like using them in my tube amps. And from what I remember, they are pretty low noise as well. Although I haven't really done any measurements on that. Okay, so that would be it as for the destructive tests of electronic components. That was Kerry, the vacuum tube witch, signing off, saying bye!